Welcome. Today we're going to continue our Fizzbuzz problem solution. As we recall, problem statement, we're supposed to print out the numbers 1 to 100, replacing multiples of 3 with the text fizz and multiples of 5 with the text buzz. If a number is a multiple of 3 and a multiple of 5, then we should print out Fizzbuzz. And we constructed a program last time which did just that. But we pointed out that in interviews, often when you've presented the solution, that you'll get a follow-up question, something like, okay, now change your program so that multiples of 7 will print out Baz, multiples of 3 and 7 will print out Fizzbuzz, multiples of 5 and 7 will print out Buzzbaz, and multiples of 3, 5, and 7 would print out Fizzbuzzbaz. I don't actually think there are any multiples of 3, 5, and 7 under 100, between 1 and 100. But well, let's actually try to do that. Let's extend our program to do that. Now, the first thing we can do, obviously, we can add a new mul function. So we could do this, for example, mul 7, and then we have mul 7 n equals if n mod 7 equals 0, then message Baz else n. Now that's fine, it's not a problem, that's correct. But when we look at these three functions, mul 3, mul 5, mul 7, and we can see there's a certain degree of repetition. It would be nice if we could abstract this, I think. So what we're going to do instead is we're just going to define a function mul of, and mul of will take a number m, a string, let me just move that, a string and a number n, and it will be as follows: if n mod m equals 0, then message ss else num n. Right, then mul 3 just becomes mul of 3 and then fizz. Mul 5 just becomes mul of 5 Baz, and mul 7 and becomes mul of 7. Sorry, this should be Baz, and this should be Buzz. Okay, that's nicer. So if we're going to add another, mul function, well, again, it's a lot less typing, and just because we type less, there's less chance we'll make a mistake. So it's just nice and neater because we've abstracted the pattern into a function. Okay, so now we know what we have to do for our test. We have to add, mul 7, and what we're going to do is we're going to have to combine mul 7 with our mul 3 and mul 5 test. But at this point, I would like to just compile this just to see what the compiler says. Okay, so if I go, yes, you see, mul 7. Oh, is it? Oh, mul 7, mul 7. Yeah, that's not what I was. That was just my mistake. But if I go here, okay, I think it's. Well, if we look at this, there's a problem here. The problem is, in fact, let's just solve the problem. what we're going to do is we're going to do that. So we're going to say that basically first we'll test for mul 3, and then we'll combine the test for multiple of 3 for multiple of 5, and then we'll combine that for multiple of 7. That will help our case analysis here easier in that sense. Okay, because this case is done for us already. So all we need to do then is just add the cases for mul 7. Now let's go through them. The first option is that the n is neither a multiple of 3 nor a multiple of 5. In which case, what we'll do is we're going to have num n here, and then combine that with the result of this, which will assume for our first case that again it's also not a multiple of 7. So in that case, that's the same as that. That's the same as this case here. So we don't need to worry about it because we've done it. The next case is that is a multiple of 3. So in which case we're going to have fizz here, and it's not a multiple of 5. So all of this will be fizz, message fizz, and it is a multiple of 7. Okay. So because if it's not a multiple of 7, then it's num n. That's already this case here. So we get message Buzz. That's right. Okay. And in this case, we know then it should be message Fizzbuzz. All right. Next case, it's not a multiple of 3. It is a multiple of 5. So in that case, we're going to have message Buzz. If it's not a multiple of 7, then that would be num n, and that's just num n here. Okay, and we'll get, of course, message Buzz. Okay. The next case, it is a multiple of it's not a multiple of 3. It is a multiple of 5. So this is a message Buzz again, but it is a multiple of 7. So that would be message Buzz. And sorry, no, it is a multiple. So then Buzz. And then we get message, it should be Buzz. Okay. Now the final case, it's both a multiple of 3 and 5. So in which case it would be message Fizzbuzz. That's right. Fizzbuzz. And it's not a multiple of 7, so that would be num n. In that case, we should just get message Fizzbuzz. Okay, and then the final case, it is a multiple of 3 and a multiple of 5. So we Fizzbuzz here, and it's a multiple of 7. That would be message. I think writing Buzz. It should be, of course, Buzz, shouldn't it? Buzz and Buzz, and then of course answer would be Fizzbuzz. Fizzbuzz and Buzz. Okay, and there's one case that I missed out, and that kind of shows the problem with this approach. But the case that I missed out was when it's a multiple, it's not a multiple of what do you call it? It's not a multiple of 3 and 5, but it is a multiple of 7. So that will give us message. That should give us message pass. Okay. Now, okay, but I think we're fine enough that we can see the problem with this approach. The problem is there are too many cases. Suppose we had to add yet another. So we say we wanted to also print something if it's a multiple of 2. Well, we then have to do all the cases, we have to do all the interactions, and it's just not good. It's not good at all. It doesn't look good. It doesn't feel good. We can't be sure we've covered all the cases. We make a mistake. So we need to reduce this. So the key observation is to note that if you look, whenever we combine something with num n, we get the thing again. So if we combine fizz with num n, we get fizz. Yeah, right here. If we combine buzz with num n, we get buzz. And if we combine baz with num n, it is here, we get baz again. So combining something with num n doesn't change. You get the thing again, which is to notice, and it doesn't matter whether you combine it on the left, as in here, or you combine it on the right, as in this case. In this case here. Okay. Now, the way we say this properly is we say that for any n, num n, I'll write that here, num n is the unit element of nabla. For any n. For any n. Okay. So, for example, 0, the idea of a unit element is a very important, very powerful one in programming. For example, we see it, if I do another comment here. For example, 0 is the unit of plus. Because anything, because x plus, because x plus 0 equals x again. Another example is that let me put it here. Another example is that 1 is the unit of multiplication, because x times 1 equals x, and also 1 times x equals x. So in our case, we're saying that num n is the unit element of nabla. So that means that x nabla num n equals x, and num n nabla x equals x. Fantastic. So in just those 2 lines, we've dealt with all the cases. So we've dealt with this case, so we don't need that case anymore. We've dealt with this case, so we don't need that case anymore. We've dealt with this case, because we don't need that case anymore. We've dealt with this case, so we don't need that case anymore. We've dealt with this case, so we don't need that case anymore. And we've dealt with that case, so we don't need that case anymore. Wow. So we got rid of all those cases with just these 2 lines. Now let's just clean this up so it looks nicer. I don't need to say that because I already said it here at the bottom. And this, there we go. That's nicer. That's much better, much cleaner. So can we do the same thing here? Can we clean up this case analysis? I noticed then that if we introduce another message, another thing, so like biz or something, we don't need to change this. We don't need to change this at all. So we've not only dealt with all the cases that we've had, we've dealt with all the cases that we could possibly have with regards to numen here. Fantastic. So can we do something with this? Well, let's look. Message fizz buzz, you get fizzbuzz. Fizzbuzz, you get fizzbuzz. Buzzbuzz, you get buzzbuzz. Fizzbuzz, buzz, fizzbuzz and buzz, you get fizzbuzz buzz. Is there a way of summing this up in a nice way without all these different cases? Well, yes, because what we're doing is we are saying, so say we have a message xx, let's call it ss, yeah, and nabla message t. Then what we should get is a message that is ss, so it's this message concatenated to this message tt. Okay, so this fizzbuzz is fizz concatenated with buzz, fizzbuzz is fizz concatenated with buzz, buzzbuzz is buzz concatenated with buzz, and fizzbuzz is fizzbuzz concatenated with buzz. So with just that one line, we've removed all these cases. Boom. Isn't that much better? That's a lot better. That's a lot nicer. Much nicer. Okay. So let us, in fact, let's try this out. I will build this. Yeah, okay, that's built. So then if I reload, yeah, okay, and I do main, yep, so 98, let's just check. 98 is 98 a multiple of 7? It is 14. Okay, I should probably have done, yeah, okay. So we've got fizzbuzz, so it's 84. So it's 84, we got fizzbuzz 84, so 84, is that a multiple of 3? Yes. Is it a multiple of 7? Of course it is. So you see we got our, it's working. I don't think we got any fizzbuzz buzzes though, because I don't think, well, in fact 3 and 5 are prime, 3, 5 and 7 are prime numbers, so the first multiple should be 3 times 5 times 7, which is 105, so that's why we don't get it. But what we can do is, if I just extend this to 105, then I build it up, then I reload. Yep, we get Fizzbuzz Bass. Fantastic. So, isn't that nice? We've got a much shorter, nicer program, and now whenever we want to add a new a new case, all we need to do is just one line. So let's say, for example, we want to deal with let's say multiples of 9, for example. Then the only thing we need to do is one line. We just do mul 9 equals mul of 9, and we'll say biz. Let's say biz. Okay, that's it. So we just do that one line. We build, and then, and just like that. If I go, let's see. Oh, I didn't do something. There's something I forgot to do. We need to obviously add it to the test. We don't add it to the test. We won't do it. So we gotta add two. We gotta add one line. Then we gotta do this. Just add another test. Mul 9. Okay. Then we build that. And oh, I haven't got the brackets right. But it is revealing a problem, isn't it? Oh, okay. Okay, I put extra brackets. But we'll come back to that in a second. What I want to do here is reload. Oh, it should be mole. Oh, so it should be. No, that's right. Mole 9. That's right. Mole of 9 bees. I think it's an issue with the brackets, yeah. And then, yeah. No, that's right. I got the right brackets. So what's the error? Oh, of course it should be mole 9n. Ugh. So we need to do two things. We need to add this, right? And then we needed to add this. But of course we had an issue with the brackets, which I'm going to come back to in a second. But let's just... Oh, because I haven't built it. Save, build, and then... Okay. And there. We get biz. Of course we'll always get Fizzbuzz. Because of course, if something is a multiple of 9, then it is a multiple of 3. So we'll never get biz by itself. If we go to like 9, for example, it'll be another Fizzbuzz. Yeah, Fizzbuzz. So we'll always, which makes perfect sense. We would, yes. So you notice that our program is still working. Yeah. So that's really good. So we were able to just with one line here and some same with brackets here, we were able to then just add another case. So if we want to add another case, we just add another more line here, and then we'd have to add the brackets to do 11. But as we saw, there's an issue. As we add more and more, the constructing our test here becomes harder to do. So can we improve this? Well, I believe we can, and we'll look at just how to do that next time. Until then, take care.